So that's a critical question. You have 2 minutes and tell me where you read the sentence here. This is about English testing. You have to know about logic if you want to answer this one properly. One answer. Vin go first, and he confirmed. He said that the condition from A to E must be understood a sufficient condition. Sufficient condition. This is one answer, and I give the whole class 1 more minute to wait. Is there any other idea? And I will give you my answer. Okay. So this is first choice. Will say something. Okay. Wow. What do you say, Wow? Lai Vin. Vin go first. And another guy confirm. Good. But Vin got contribution. But wow, I don't know. But let's say. Anything else? No one answer all the things, right? 30 more seconds. So the answer is sufficient, correct? But I asked another extra question. Ask okay? Listen carefully. Wow. What if I don't employ the word, the letter here? I don't say when, okay? But I change my question to be this one. Then what can you tell? Wow, and the whole class. If I don't use when, but I use then. The same question about A, B, C, D, E. What is your answer then? Are they still sufficient? Or say same? He asked me. And about the class, what happens if I change my question like this one in the slide? I don't say when, but I say then. What is your opinion, the class? Vinh, any idea? Quyên, Hằng, Đức. Vinh confirm. We have to change the conclusion. We have to say that if I change the input from when to then the A, B, C, D, E must be necessary. Very good. So only Vinh get the bonus today. 2 time correct answer. So good. So I go back to the original. I don't have then I go back to the original. Then this is the solution for you. The right answer for this multiple choice question will be item E. None of the above. So that means A, B, C, D are all wrong. They cannot be sufficient condition. And I explain here about item C why we say C cannot be the sufficient condition for isomorphism. because this one clearly, right? We talk about C, we talk about the number of connected components are the same, but unluckily the number of connected components is just one invariant, not sufficient. Then you may ask me what is the correct sufficient for this, and you have to modify item A. So this is one way to modify and get the right sufficient condition. You have to modify item A, and this is my suggestion. Okay, the map not only just bijection, but also require the maintaining neighborhood of the vertices. Okay, you have to write full requirement like this to modify A. Okay, to be something A new. We can say that, and the A new with the extra condition here can be sufficient condition for graph isolation. That finished. Okay, so we move on. So we don't have more time, so I have to go very fast. But idea is, any difficult problem, I provide a hint for you. You should try yourself. This is about the yes. Now you understand, right? A, B, C, D, E here become the necessary condition. Okay, because you start from isomorphic graph, and we have. That means, like Yin said, the condition here, A, B, C, D, E here, turn out to be the necessary condition, right? And the answer here will be E. Interesting, E. And E means any one of the above will be okay, correct? Because they are all draft invariants. Okay? So, and you can check that by looking to the adjacency matrix. About bipartite, the fourth group. Today, the last day, so we may employ some extra time, okay, if you don't mind. So, problem number one, yes, in the fourth group here about bipartite. Very short. Wow. We provide a condition for a graph to be bipartite. And IFF here means both condition. Okay. So when you read the textbook, you see IFF. So we understand it means if and only if. Okay. Then we can say both. The condition in the right hand side both sufficient and necessary condition. Okay, we can understand that the both conditions, that means we can say if and only if means full condition to get the outcome. If and only if means full, both sides. The full condition to confirm something. To confirm means sufficient and to employ it. So informally you can say that. So the problem here is about that. Okay, we provide condition both sides, both way for bipartite, and the condition say every cycle in the graph must have an even length. Wow, very short sentence. And how can that be? Wow, Well, only one way to believe, by proving that mathematically. So that means two way, from the left to the right, that means necessary. You start from bipartite first and you prove the right hand side. And also the other way around, okay, the sufficient condition. So that means you will play the role of the assumption here. The cycle have even length, then the graph must be bipartite. And this is the proof. And one sentence but cost you one page. So you have to read that one because this is the full, meaningful, very valuable hint for you to understand about the Bible. I give example by looking to this one, to provide a picture. Oh no, this one picture about the matrix. Okay, figure number 9. Figure number 9 means a graph, and we ask you to draw the matrix B, adjacency matrix, recover the matrix. Okay, but also illustration for the question number 1 about bipartite. Because you can define the first part of the vertex will be the blue with the vertices V2, V4, V6, and V8. So this is a bipartite graph if you classify the group of vertices in that way. Okay, the disjoint union of the first group V2, V4, V6, V8 in capital A, then you get the union with the second group from V1, V3, V5, V7, and V9. And that disjoint union gives you the idea of this bipartite, you see? And by definition, the connection only can go from A to B, you see? V1, V2 from A to B, right? V4, V3 from A to B as well. Okay, so this one is good for bipartite, and you can check the condition. Any cycle here must have even number. Yes, this is the cycle. This is the cycle, and you count how many edges here. Exactly number 4. You see, so the theorem is fulfilled by looking to this example. So that's fine for this one. So we hope that you continue the group number 4 about bipartite. Then we go to the shortest part about Dijkstra, and the Dijkstra I believe you understand well, right? The idea, the algorithm here, the shortest path from the source to the sink, and the equation number 1 I explained a few weeks ago help you to realize the Dijkstra to find out the shortest path. Okay, this is equation number 1 in my lecture DS number 9 few weeks ago, to update the label of the vertex in Dijkstra. And you should try to do this one for yourself, because the lecturer in your department, your faculty, they like the Dijkstra, because this is good for traffic jam solution. In the human city, traffic jam happening every day. So, well, so this is the group number 5 about shortest path problem. Now we move to the second bigger one about identity entry. Yes. So the 6th group here, we review about identity draft. I provide a full set solution for you so that you can learn yourself after today, because today is the last day, right? We don't have time to extend. This is the final. So the solution here is good enough and very clear enough for you to self-study, right? So the identity draft may be just one thing. This one don't need to study, maybe at your level. Okay, let me say in the chat box here, do not need to study session 5.7 about the group number 7 for the final exam. Okay, so we skip that one. So we skip this one for the final exam. We don't ask any question about the concept here in the group 7. Okay, very complex, so we skip this one for this year. Under COVID-19, we don't talk about reachability matrix. No. Okay. Now after that we go to the tree. Beautiful subject, and we just learned last week. Okay, the property of the tree here. Definition number 1 here. This is the summary. Summarizing part. The summary for entire tree theory. Okay. Definition, property, then theorem 1. Yes. We have 4 equivalent definition. Yes. And I promise to prove the fruit, and I give 1 for you here. And I say row number 2 to number 3 will be obvious. Number 3 to number 4 by contradiction method. Contradiction is not contrapositive. No. Okay. Contradiction logically mean you want to prove something we call A, you want to prove B, but you cannot prove directly. So the contradiction method means you can replace by proving the right hand side like this. Look carefully into the chat box, please. One few more moments and we finish. You cannot prove directly, so you replace by the right hand side here. And see. So that principle we call the contradiction method. With the contradiction, you have richer, bigger assumption. You combine A with not B, and you have to prove something false. Okay, and you apply to prove item 3 to item 4 in this theorem, and the last one do it yourself. And the second theorem we talk many times, so I don't say a quantitative result. And one more, yes, this is the proof for that, I promise, and this is the proof. You can follow this one to prove yourself. And then multiple choice question, and this is the answer for that. And there are some case symbol. This is the test for the tree, the test for the tree, the test for the tree, and then some other tests about the forest, computing the number of connections inside the tree, and I think that's enough for the whole class. Okay, because we don't test in the final exam about the flow, so we can say formally to review for the final exam, everything here is enough. So we are done everything for the discrete structure for this semester at HCMUT in your international program. Okay, any question, guys and ladies? So this is finished part. We done everything today in the final days, but you can ask me some questions right now if you want before we finish. guys and ladies. Anyone? If not, then may I suggest that we show the video. I would like to take a photograph for souvenir. Everyone should be show your image, please. The video should be turned on. So because this is today the final session, so making a photograph for souvenir and we finish. The final exam day, you should ask Dr. Tuấn Anh, huh? Okay, he will know because that will be checked with the OISP office as well. I am not the guy who decide the day for your exam. The people in HCMUT will decide that day for you, right? And you should ask them, huh? I fulfill my duty about providing the theory and also the solution for everything in this structure, and hopefully in the future, maybe next year or next semester, we can work together in other matter, other subject, maybe modeling or something else, more specific. Maybe in 4 years, in your final year, there are some more advanced, mathematical application in computing. But right now we finish, and one more second, I press the button, and the movie I will upload to your to my drive. I give you the link and you can get there. 1, 2, 3, and say cheese, everyone. Okay, thank you and bye bye, everyone. See you in the future. See you around. Bye bye. When ask something happen, now you can turn on your audio. This is the extra part. We can chat via video, audio if you want to ask in words. Maybe in Vietnamese because this is out of everything. Okay, so I allow you to talk with me in Vietnamese. Yes, Vinh.
Okay, can you hear me?
Yes, say yes.
Yeah. I want to ask about those bullet points that you gave it to us. How would you apply that to our final score of the course?
Good, understand. Because you get some extra point, right? So I think I will provide the bonus point to the examination guy, the examiner, the teacher in faculty, or I could involve directly to the evaluation as well. Then assuming that the maximum score will be 40, let's say, okay? Then you get only 33, understand? Then you got the bonus, let's say number 5. So that means the final exam will be 33 plus 5, and you get 38 points. Understand?
Can you say that again? It was a little bit loss of connection, so I cannot see your full answer.
So the final score I will plot in the chat box will equal to the real score you got from the exam, then plus with the bonus score you got when you learn with me. Okay? Understand?
So the final score, you mean the average score?
No. Only the score for the final examination only, not
Okay.
okay. So if
Okay.
if we say the maximum score for that will be 40, and you got in the real exam 32, and you got 5 bonus, understand? Then you get the score for the final exam will be 37. You see what I mean?
So if like the score, the next score is 10, and the normal score is 10, and I get like a 7 or an 8. So how would you apply it?
We don't know the maximum score for the final exam. That depends on the lecturer there. But if I assume the maximum score for your final exam paper will be 40, and you got the real score from the exam only 32, understand? And
Yeah, yeah.
you got with me 5 bonus score, then you get in total 37.
Oh, okay, okay.
Understood, right? Good.
Yeah, yeah,
Okay. You tell your friend about that scheme. Uh-huh.
yeah.
I will make sure that the bonus score will go to the lecturer there if they become the evaluator from of your exam. Uh-huh. Okay.
Yeah, okay.
Okay.
Uh, could you send us the record of the people who got the bonus points and how many they got? How many they got?
Sorry. When say again.
Can you send us like a record of the people who have bonus points and how
Ah.
many bonus points they got?
Understand. You want to see the bonus point from your class, huh?
Uh, yeah, because I don't keep track of how many points I got.
Sure. You want to know?
Yeah, yeah, yeah.
So please prepare the note. I will read for you the name of the student and the score. Okay, bonus